We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Millions of miles away, whether or not life was actually possible on Mars at some point in the past. With me in the studio is Andrew Coates from the UCL Mullard Space Laboratory. A very exciting moment, this, really, in space exploration.
Very much so. It's a really exciting mission to go and look for the signs of habitability on Mars. We don't know of any life beyond Earth at the moment. That's the only place where we know of any life in the universe. And so Mars is our nearest neighbour. It's somewhere where conditions may have been right about 3.8 billion years ago for life to form. So the idea for this is to actually land in this crater, to look at sedimentary rocks, really, which are in there in the crater, or layers of rocks, really, which tell us about the age of Mars. And look for things like carbonates. That's one of the sort of key things which this mission is going to be doing on the surface of Mars. They've been seen from orbit, but they haven't yet been seen on the surface yet. There have also been signs of methane in Mars's atmosphere. So, you know, Mars is trying to tell us something that that there could be signs of life there, either past or present. So, the conditions for life include having a presence of heat, having liquid water, that's the thing which a lot of the missions have been looking at up to now, and also having carbonates and the right chemical substances, and enough time for life to actually develop. And so this is, you know, we don't yet know whether life was there or not, but this mission will help us in trying to find out.
Indeed, and all the experiments and all the analysis will actually be done up there by this rover. I mean, it's one of the most sophisticated machines to do this kind of thing we've ever seen.
That's right, it's very sophisticated. We're seeing the landing at the moment. This is the landing system which will actually try to get it to the surface. Once it's on the surface and has successfully landed, there are a number of instruments. So there's imaging, obviously. There's also, intriguingly, a laser which will be fired at rocks nearby to sort of vaporize those, small amounts of those, and then do some analysis of the surface, looking for carbonates again. There's also a hand lens experiment, almost, a sort of geologist's hand lens. You can imagine, you know, going there with a magnifying glass. That's what one of those instruments will be doing. So altogether there's about 10 instruments. There's also a weather station and other things on the surface. And it's an amazing feat of engineering to have a rover this large which is going to be doing that. Then in a few years' time we hope to go beyond this and actually look for signs of life, and that is a really exciting mission called ExoMars.
Absolutely. It's hard to believe, isn't it, that, you know, back at the beginning of the solar system, billions of years ago, that Mars actually had flowing rivers and water and all the things that suggested that possibly life might have been there.
That's right. So it had an atmosphere very much like our atmosphere now. It had a magnetic field, it had volcanism, so it's a living planet at that time. What we don't know is whether there was actually life on that planet. But it had all the conditions. I mean, from what we know from the evidence so far, it looks like conditions could have been right. But we're trying to sort of go beyond that and try to get more detail on that with this mission. And then the next step is to drill underneath the surface up to 2 meters, because the surface at the moment of Mars is very oxidizing, and there's also a radiation environment. You have to get underneath the surface to be able to do that. That's not going to be possible with this mission, but the next one, joint European and NASA mission called ExoMars, that's what we hope to do in 2018.
2018, we've got about a minute to go, I understand now, to the launch if everything is going according to plan. The problem, of course, with getting to Mars is its atmosphere is very thin. It's difficult to land things there, and a lot of attempts by scientists to get probes onto the surface have failed.
Yes, that's right. We were involved in Beagle 2 in 2003, which sadly didn't get to the surface correctly, but other missions have, so it is possible to get to the surface, but it is very difficult. It's almost the sort of Bermuda Triangle of space exploration, really, getting to the surface of Mars and even getting into orbit. There are missions which have failed to do that as well, including one which was launched a couple of weeks ago by Russia. But hopefully now this will be going correctly, and it's about
right.
To be
okay, I think we're actually going to listen in now to the countdown to launch.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Main engine start, 0, and liftoff of the Atlas V with Curiosity, seeking clues to the planetary puzzle about life on Mars.
Heavy program is in right on time. 180 operating on the first thrust as expected. And throttling down to 76%.
There she goes, smooth as clockwork by the looks of things. Andrew Coate, hopefully you'll be hoping for that kind of launch in 2018?
Absolutely, so far so good. There's a lot of stages before the mission is a success. I mean, it's got to do the separation of the solid rocket boosters, which are strapped onto it to help it get off the ground and to help it with its first part of its flight. So that has to happen, and basically it's about 50 minutes, something like that, before we know whether the thing has separated from the spacecraft correctly. Because right at the moment it's obviously going through the atmosphere. It will have gone through, or it's maybe about to go through Mach 1, so going greater than the speed of sound. So it's really from a standing start on the launch pad, and of course extremely good acceleration to actually go off into the atmosphere. In contrast with the rover, when it actually gets to Mars, it's going to be actually a very low speed rover, something like 0.1 of a mile per hour or something.
Wow. So it has to slow right down in order to land in a way that isn't going to damage the rover.
Yes, the landing system is the first time this has been tried, and so the idea is to actually slow it down, first of all using Mars's atmosphere, which slows it down to some extent, and then to use retro rockets with the rover underneath, and we can see that on the right hand side here now after the parachutes have happened, and so the rover's underneath that aero shell. The wheels deploy and everything, and then the spacecraft sort of separates away from that. The retro rockets slow it down as it goes towards the surface, and then finally it comes out on basically wires, umbilical cords from the parent spacecraft to actually land it successfully. So the idea is for this to be a much more accurate type of landing system than has been done before. So we can see it will land deployed with the wheels out and everything and ready to go. Because the difficulty of this type of size of rover, which is about the size of a Mini Cooper, that type of size, really quite large. Difficulty of that, landing it on a landing system and then driving it off it. You can avoid that with this system. So this is the way to be getting a heavy thing like this. It's 900 kilograms getting this to the surface, so it's really exciting. But 900 kilograms, of course, is large for a rover. But considering that rocket when it took off, and we saw it just now, something like 500,000 kilograms. So most of that is fuel to get it first of all into orbit, to take it on its trajectory to Mars, and then the landing system itself, and then the landing successfully. The landed mass 900 kilograms on the surface, which is unprecedented in space exploration.
Wow! And this is what, an 8 to 9 month journey?
Yes, it gets there on the 6th of August next year. I think it's something like 6 o'clock in the morning to 6:30. We know the time that it's going to get there because Isaac Newton has worked that out with his equations of motion, and once you've launched it, there's not much you can do about changing that. There are minor course corrections which you can do, but basically we know that is the time when it will land. So 6th of August it will get there, and hopefully that landing system, it's been described as 6 minutes of terror of actually getting that thing to the surface, because it is a complex
That's the really
system.
scary moment, isn't it? Really?
It is, yeah, because it's difficult to test all that together in Earth's gravity. So that doing an end-to-end test of it, as we call it in the space business, it's difficult to do. But nevertheless, the things have been tested individually, and tests have been done to make sure that it's going to be able to do it. So they're very confident. And that's why we're confident in putting our future rover on there, that this is, when I say we, this is the European Space Agency ExoMars mission, which has been joined with a NASA mission which will be going there in 2018. So the European part will be drilling under the surface to look for signs of life under the surface, either past or present, but actually doing the chemical analysis for that. Whereas the current mission, this one which has just gone, is going to be looking at whether conditions were right or not. We're actually looking for life with the European mission, so it's very exciting.
Okay.
And then the NASA part of that mission will be gathering samples ready for an ultimate return from Mars to the laboratory with samples from Mars. So that is the sort of geologist's dream, you know, to be able to get samples from Mars back, do much better measurements than you can do on the surface, actually in earthbound laboratories. But for now, this is a wonderful step in space exploration.
It is.
So far, so good. And
everything seems to have gone according to plan. But is there the possibility that once the rover gets there and it starts analysing the rocks, that it actually sort of finds that actually the conditions might never have been right?
It's possible, yeah. I mean, you know, the reason for doing research, we don't know the answer, you know, so we have no idea whether life could have been there or not. Of course, in that case, then maybe we haven't looked at the right spot with this one. All the indications are that it probably is one of the right spots to look at. There are signs of clays at the bottom of this cliff in the middle of the crater, which means that there was water there once. So it's a good place to look, but it's not necessarily the ultimate answer if we don't find life there. Or we don't find the conditions for life there, because it's looking for conditions for life, it's not looking for life.
All right, we'll leave it there. Andrew Coates, thanks very much indeed for guiding us through all that. It's good to have you in. Thank you. It is 8 minutes past 3 now.